Hi everyone, welcome back to VRC Smart YouTube channel. So today we are going to see the NCRT examples of concentration terms. So already have made the video on concentration terms, and if you have not watched the video then go and kindly watch it. So now we are going to start with the examples of concentration term. So there are three examples in NCRT given based on the concentration term. Now let us try to solve all those three examples. So this video will be very short, where we are only going to discuss the examples. We also have in-text and example questions. So I'll separately make in-text video all the way. I'll be discussing all the in-text questions of this chapter, and I will also make a separate video for exercise questions. So we'll discuss each and everything in detail in separate video. But now we are going to discuss the examples of concentration terms, because you have to concentrate on example first. Okay, so actually it is a physical chemistry, so you have to concentrate more on example, exercise and in-text questions. Okay, so now we will move on to NCRT example. So example 2.1, what is given? Given is calculate the mole fraction of ethylene glycol. Ethylene glycol formula is given in the question, of solution containing 20% of ethylene glycol by mass. So already while teaching the concentration terms, I would have told you what do you mean by 20% of mass, right? What do you mean by 20% of what? Mass. What does it mean? I would have told you that 20% of ethylene glycol, that is C2H6O2, that means what you can say is 20 grams of ethylene glycol C2H6O2 is present in 80 grams of solvent, maybe here water, 80 grams of solvent. Clear? So totally your solution should have 100% of the composition, therefore 20 grams of ethylene glycol present in 80 grams of water. So mass of ethylene glycol is 20 grams. Clear? Now what is a mole fraction formula? X of A is equal to N of A by N of A plus N of B. This is a formula. So now you have water and you have ethylene glycol. So first you have to find the number of moles. Okay. So first for that you have to find the number of moles. Number of moles is equal to given mass by molar mass. Given mass by molar mass. So here you have to find the molar mass of ethylene glycol. What is the molar mass of ethylene glycol? So for carbon it is 12, 2 into 12 plus, for hydrogen it is 1. So 6 into 1 plus oxygen it is 16. So 2 into 16. If you solve this one, you will get the molar, that is you will get the molar mass of C2H6O2 to be around 62 grams. 62 grams you will get. Okay, 62 grams mole inverse. Now to find the number of moles of, I'm finding here number of moles of C2H6O2. So to find that, first you have to write a given mass. Given mass is 20 grams, right? 20 grams by molar mass is how much we found? 62 gram mole inverse. So now what happens? Gram will be getting cancelled. So you will get, and again when you just do certain perform calculations, you will get around 0.32 moles. You will get around 0.32 moles. So now we have calculated the mole of N2C6H2, N2C6O2. Now you also need to calculate the number of mole of water. Why? Because Na plus Nb is there. So number of mole of water also you have to calculate. So for that I am taking, listen, see, listen, I am taking N of H2O. So your N of H2O will be So now molar mass of water is how much? It's standard. Most of the areas you will use. So remember 18 gram mole inverse. This is a molar mass of water. So you can remember it standard wise because it is a stable molar mass. So molar mass of water is 18 grams. So what happens? The given mass of water is 80 divided by the molar mass is 18 gram mole inverse. So substitute always when you do the calculation, substitute with the given information. So gram gets cancelled, and when you just do the cancellation you will get 4.44 moles, somewhat like this you will get. So the calculations are over. Now moving on to this side. So n of, now we are calculating the we have calculated the mole fraction already. Now we are going to calculate, so we have calculated the required number of moles. Now I am going to calculate the mole fraction. So how can we calculate the mole fraction? Tell me, how can we calculate the... So if you just see x of C2H6O2, that is a mole fraction. So your mole fraction will be equal to Na. What is Na? Na is 0.32 moles divided by 0.32. Na plus Nb is 4.44 moles. Now you just add the bottom and you just divide to the top. You will observe around 0.068, and it is unitless, therefore you leave it without putting any unit. Okay, it is unitless, so you will not put any unit. C2H6O2, you know certain value. Okay, certain value you know, that is equal to 0.068. Now how can you calculate x of H2O? You can very easily calculate x of H2O because x of C2H6O2 plus x of H2O equal to 1, because with this formula you can calculate the x of H2O. Okay, listen. So x of H2O will be how much? X of H2O will be equal to 1 minus x of C2H6O2, that is 0.068. So after performing the calculations, finally you will get the answer. Now if the question is asked for you to calculate the mole fraction of water, how would you calculate the mole fraction of water? So you have already learned, I've already taught you in the theory part. So using that we can find the mole fraction of water. Clear? Now what I told you clear? So that is what I am going to follow over here. So 1 minus, we are going to have 0.068. Okay, so when you do this, you will get around 0.932. So this is a mole fraction of water and it is also going to be unitless. That's it. The question is over. Okay. So now let's move to the next question. It is example 2.2. So let me read the question first. Calculate the molarity. So already we have discussed the formula for molarity, right? Of a solution containing 5 grams of NaOH in 450 ml of solution. So how can we solve this one? Before solving in hand, let me give you the formula of molarity. So molarity is represented with capital M, or I'll write molarity. Molarity is represented with capital M. Molarity is equal to number of moles of solute by volume of solution in liters. Correct? So this is what your molarity means. Now, first you have to calculate the molarity, then you should know the number of moles of solute. But they have told that the solution containing 5 grams of NaOH in 450 ml of water. That means your given mass is 5 grams of NaOH. So you have to calculate the molar mass of NaOH. That is not given. So what is the molar mass of NaOH? So for that you should know the molar mass of first atomic mass of sodium. Sodium is 23. So actually 1 into 23 plus 1 into 16 plus 1 into 1. When you do this, you will get around 40 grams, right? 40 gram mole inverse, right? So 1 into 23 is 23. 23 plus 17 you have to do. So 23 plus 17 is, you would get around 40 gram mole inverse. Now, what we are going to do is, for finding N of NaOH, what you should do, given mass by molar mass, given mass is 5 grams, by molar mass is 40 gram mole inverse. So you have to just cancel it. Okay. So while cancelling the number of moles of NaOH, you will get around 0.125 moles. 0.125 moles. Now, molarity is equal to number of moles of solute. I am writing it as 0.125 moles. But your volume of solution should be in liters. If your volume of solution should be in liters, you can directly substitute in formula. But the volume of solution is present in ml, 450 ml. So ml, in the sense, you can't directly substitute. So ml to liter, how can you convert? So by dividing 1000. So if you divide by 1000, it goes to the numerator. So you can multiply in the numerator 1000 by 450 you can do. This is one of the formula. Also you can remember. Like I'll write and show it over here. Okay. Like a formula you can remember this one. Okay. So your molarity can also be written as number of moles of solute into 1000 divided by volume of solution in ml. So as a formula also you can remember this, but you just need to understand, because more number of formulas you can't by heart. So understanding will help you to change your formulas according to the situation. So try to understand. Okay, so I hope you understood what I am coming to tell. Okay, so now let us solve this one. So when you are solving this complete equation, you will get your answer to be around 0.278 molar. So you can either write it as molar, or the molar can also be written as, see, this actually, this is number of moles, right? This is ml. So you can also write this equation as, okay, so you can also write this as 0.278 mole liter inverse. That means bottom only ml is there. We are converting it into liter. For that we are multiplying 1000 to the top. So mole is at the top, liter is at the bottom. So while bringing the bottom to the top, your unit will be in inverse condition. So mole per liter is only written as mole liter inverse. This is nothing but mole by liter. That is the meaning of it, right? Very simple. So here you have to be very clear with the calculations. So you have to practice a lot of problems so that your calculation power will increase. So I am just telling the methodology for you. In this way you have to start your sum. These are the things that are given. These are the things you can take. So this is how you can calculate. This is what I am telling. But the calculation part, you know maths, right? So you have to calculate. You should know the short tricks, where to use the short tricks, and how to calculate. All these tricks you should know in calculation. That makes your calculation easier and faster. So try to make your calculation easier and try to make it faster, because in exam you don't have much time for spending in calculation. So make it faster and easier. That is the only tip that you have to follow here. But all the methods are same. You can use the same method and you can easily solve the problems, right? So next question, based on the molality. Now, what is a given question? Calculate the molality of 2.5 grams of ethanoic acid. Ethanoic acid formula is given CH3COOH in 75 grams of benzene. Okay. So let me write the molality formula, right? First I'll write the formula for molality. Hmm? So it will make better for us to get calculated. So first I'll write what is your molality or small m, that is equal to number of moles of solute, number of moles of solute divided by mass of solvent in kg. This is a usual formula for molality. So, coming to molality, they have given 2.5 grams of ethanoic acid is dissolved in 75 grams of benzene. That means 75 grams of benzene is what it is the, actually 75 grams of benzene is the mass of the solvent. So, mass of the solvent is 75. Mass of the solvent is 75 grams. What is the solvent here? Benzene. C6H6 is the solvent. It is 75 grams. Now, number of moles of solute. Ethanoic acid's number of moles you have to find. So, number of moles of ethanoic acid CH3COOH, that is going to be equal to given mass. Given mass is 2.5 grams by molar mass of CH3COOH. You have to find how to find the molar mass of CH3COOH molar mass. Okay, how many C is there? 2C upper. How many C is there? 2C is there. Then you should have 2 into 12 plus 3 plus 1, 4. 4 into 1 plus 2 into 16. If you do, you will get the molar mass of CH3COOH. So your molar mass of CH3COOH is going to be 60 gram mole inverse. So 2.5 divided by 60 gram mole inverse. So your gram gets cancelled, and when you do just calculation, you will get 0.417 moles. You will get around 0.417 moles. Now what we are going to do is, you are going to substitute in this formula. So actually beforehand we just saw that your benzene is present in grams. That means you can change your formula as number of moles of solute. It is N of C6H, that is number of moles of solute, right? So N of CH3, N of CH3 COOH divided by number of mass of the solvent is given as 75. So mass of C6H6, but it is given in grams, right? So you have to multiply with 1000. So that means your molality will be equal to 0.417 into 1000 divided by 75. Okay, so when you do certain, this is grams and this is moles. So when you do calculation, your molality will be somehow 0.556 molal, or you can also write it as unit alone. I am writing, can also write as 0.556 mole kg inverse. It is nothing but mole per kg. Clear? Mole per kg. So mole kg inverse or mole per kg. So maximum the similarities you can see between two different things. Okay, so that's all for today's video. Thank you so much for watching this video. So in the next video we will be discussing about the solubility. So there are two types of solubilities are present. That is going to be a very important topic and very much interesting topic it is. So very easily we can learn. Okay, so solubility we can learn in our next video. So until then, thank you for watching this video and bye from my side.